Hi, my name is Heidi Hysell, and I'm the founder of Alpha Drive. In this talk, we'll be covering the areas that will help democratize the development of embodied AI and some of the work that we are doing within the space. Our vantage point and the details in this talk will be told through the lens of the autonomous vehicle sector. Of course, the ideas and our work can be extrapolated out to any sector. We know embodied AI is a paradigm shift, transitioning from learning from data sets to interactions, with inputs being gathered from sensors and the environment, and outputs impacting the world in much more profound ways. We want to make sure that we can accelerate progress while building trust and safety along the way. For us, democratizing means making access simple and accessible to anyone. To democratize access, there are some core areas of coverage. From the data available for training, testing, and validation, the source of the data, whether that's from the real world, simulation, or controlled environments. Managing the data has always been a challenge, but so is knowing how valuable and valid the data is and the overall life cycle. It's still an open question. To the tools that we use in the development lifecycle for embodied AI, from access to compute, simulators, QA tools, to continuous integration and continuous deployment, as well as monitoring. Finally, the ability to gather feedback from different stakeholders. Stakeholders can range from internal development teams and management, industry organizations, and even end consumers. It's important that all of their voices are reflected in the process. We need to ask, what does the development cycle of embodied AI look like? This is an example from within the autonomous vehicle sector of what the development cycle evolves to become based on RAND Corporation research. Here, we go from real-world, human-driven data to simulated data to closed course data back to real world within the embedded AI. It's a continual loop. It shifts how software is developed, tested, deployed, and especially maintained. All of the data that needs to be collected along the way and continually thereafter. It gives us a clue as to the work that needs to be done with the tools, data, and feedback to enable embodied AI to be safe in a production environment. One of our biggest takeaways is that it is a never-ending cycle. The world is constantly changing. Therefore, the data that informs the environments and interactions will have to constantly evolve as well. We know that it's safer to work in simulation than in the real world for many use cases. But additionally, we need to look at where and how we generate the data, making sure that there is diversity in the process. And why does it matter? Well, in the case of cars, there are lives at stake and a possibility of embedding bias. And ultimately, we have to answer the question, how do you determine driver risk when the driver is an AI? Today, risk is based on human behavior and demographics. Tomorrow, algorithm behavior will determine the risk in every environment and scenario encountered. Data has always informed risk. We also need to think about how we acquire, maintain, and interpret that data to make sure it's accurately reflective. Where do we gather the data? Currently, insurers have a lot of data about behavior and risk. and they are currently responsible for those metrics and measurements within their actuarial tables. And that shouldn't change going forward. Just the means and mechanisms of acquiring that data shift towards the sim to the real world cycle. It becomes a part of democratizing the development and quality assurance, giving other stakeholders the ability to contribute to the data sets where they have additional insights and value to bring to the table. In a feedback cycle, it helps us to understand the AI we're interacting with. We see different insurers being able to specialize and facilitate in creating the types of test and validation data sets that need to be generated. Just as every physical vehicle has its strengths and weaknesses, every AI will as well. Some may be great at suburban environments, such as having a better understanding of school zones, while others might thrive in city environments. So we'll still have driver profiles, but these will come in the form of AI personalities, at least at first. And of course, the routes that these things drive on or the environments that they encounter matter to risk too. Now, at Alpha Drive, we actually started our journey, and we were very, very proud in 2019 to support the Karla Challenge. We built the cloud infrastructure tools in support of it. It was a contest for students, researchers, industry to create the safest self-driving AI based on NHTSA's pre-crash scenarios. And that was actually showcased at the CVPR workshop last year. We provided all of the backend services supporting the challenge in collaboration with the Karla team and Eval AI. Our goal last year was to make cloud simulation a commodity. It's not rocket science, but it's a distraction from the hard problems. And it's more complicated than this diagram depicts. But generally, we've abstracted out all of the infrastructure from cloud providers like AWS, the orchestration with Kubernetes and Docker, and the simulator integration. We have figured out the complicated parts, only running servers when necessary, focusing on best performance, especially given budgets. And this releases developers from the need to own their own hardware. Or if they do, we help them further manage and support that too. But we've given developers back the ability to focus on what matters to move forward. Within Embodied AI, there are many hard problems. Accessing and setting up the development and testing environment should not be one of them. We've taken our infrastructure and made it accessible through a simple command line interface. We've built streaming simulation as well as a fully cloud-based agent and simulator support in the cloud for developers. In streaming simulation, agents run locally and connect to a cloud simulator that pipes down sensor data, optimizing your available compute. Our CLI makes it getting started super simple. From login, to downloading a demo from a single command, where we have a YML file for setting up and configuring commands. And getting a server up and running is as simple as typing Alpha Drive. Whether doing so as a manually driven car or even with an agent. Output is available, being streamed down to the local machine as the simulator is running. Afterwards, All of the output is available on the local machine for easy access. Streaming can be done for multiple Karlas at the same time and can be configured for different types of development. Here we can see generating the map view for Karla takes a little bit longer. That is not because of the cloud, but just for setting up Karla takes a little bit more time. And additionally, we support both visual, as seen, as well as headless modes for streaming simulation. Our fully remote-based orchestration provides additional performance by running your agent against the simulator in a co-located system. Here, we push a Docker-based image up to the cloud, and we get the process up and running quickly. We can see all of the sessions of the processes that we've run. Of which these services can be run in parallel and are capable of running at scale. And additionally, we manage all of the log hosting up in the cloud, as well as providing support for you to download it all locally afterwards. And this is just the beginning. We're always looking for feedback from the developer community on what tools that they could use to help enable them to move faster. In the Karla Challenge, we were able to support over 5,000 hours of simulated driving, covering over 6,000 kilometers with 211 participants in 63 teams. And this gave us a lot of really great experience. This year, we're continuing our support with the Karla team and fully hosting the new Karla Leaderboard. This leaderboard focuses on providing fair and reproducible evaluations, simplifying the comparisons between different approaches. With the launch of the Karla Leaderboard, it expanded our capabilities. We give the ability to create benchmarks from third parties, like the Karla team, or other interested stakeholders, like development managers, insurers, or regulators. Giving these parties their own ability to create the metrics and measurements necessary in determining success. It's part of democratizing access to quality assurance in AI, providing our tools not only to developers, but involving other stakeholders in the process as well. Our admin interface is straightforward, and it has capabilities for individuals and teams where you can see all submissions from anyone, as well as the detailed logs. With an additional ability to directly message anyone with feedback on the team. Developers can submit their code for validation against an unknown environment, giving them an outside view of their agent performance, one where success measurement is common amongst all contributors. Administrators can not only see how well the submitted agent scored, but they have a more detailed view of actual performance. This creates a feedback loop to make sure that the metrics and measurements are representative and an understanding of what possible risks may still remain. This is just an example of a potential submission, not an actual submission. But we can see while the agent does perform very well, there might be certain information that wasn't measured within the performance. And while it's not measured, it does have an impact on the actual outcome. So all of those measurements can be updated. For developers, this new release takes us beyond abstracted and managed infrastructure and moves us into more detailed data management, allowing developers to use the same interface themselves for their own experiments and benchmarks. Allowing them to iterate faster. Our hope is that with these new capabilities, we'll be able to provide more and more data from different stakeholders to help developers iterate even faster. We mentioned the need for a data marketplace to democratize the development of quality assurance lifecycle of embodied AI. One where stakeholders can contribute environment and scenario data and gather results of the interaction behavior without being exposed to the AI itself. This is how we envision it, and it's what we're currently building within the mobility ecosystem. As we did with the Karla team and with the Karla Leaderboard, we are talking with insurers to provide test and validation sets based on their own data insights to provide developers democratized access in their development lifecycle. We believe this same platform is capable of accelerating embodied AI development generally, scaling to other sectors, including drones, warehousing robots, medical devices, and other AI applications we haven't developed or haven't even imagined yet. We mentioned democratized access. There are 3 core areas of coverage. We believe we have a basis to start from, but there is still more work to do to build trust and safety in these systems. And we're interested in exploring where else we can have an immediate impact. These are some of the things that Alpha Drive is working on to help democratize development and quality assurance. But democracy requires participation. So let's continue the conversation. What are other industries where this can apply? What are the challenges that lie ahead? And what else can we do to help move things forward safely? Looking forward to talking with you soon. Thank you.